So this is Dirk, and I've just breadboarded a circuit. What the circuit does is on the left-hand side, it receives 12 volts AC at 60 hertz. And then it actually measures the zero crossings of the input voltage provided by the transformer. And with a time delay, it feeds pulses of current to an LED on the right. In other words, the LED on the right is receiving 120 pulses per second. And what I can do is I can change the apparent brightness of the LED on the right. By turning the potentiometer to one side, I can turn it all the way down to off. And by turning the potentiometer to the other side, I can make the LED almost full brightness. I can vary the apparent brightness of the LED. Now, the reason, the fact is not well recorded by my camera, that at any moment in time, the LED is either on or off. There are no midway settings for the current flowing through the LED. And the way that works is that once the circuit detects a zero crossing on the left-hand side of the breadboard from the transformer of the voltage, there is a controllable time delay after which it turns on the current to the LED. And the current to the LED shuts off again when the voltage at the input performs another zero crossing. Right, so I'll show this to you again. I can change the apparent brightness as far as the human eye would see it, as well as how the camera sees it, by turning it down, by turning it up to full brightness or close to full brightness, all the way down, somewhere in between. So the question that can be asked about this is, what is the practical use of such a circuit? And the practical use of such a circuit is that the LED that I have here can be replaced by a pair of optically isolated LEDs that trigger high voltage, high amperage silicon controlled rectifiers. And the ability to regulate how much power you want to feed to a high voltage, high amperage circuit is potentially valuable in an industrial or commercial situation. Now, just as a summary of the components that I've used, the integrated circuit on the left provides 4 operational amplifiers. I only needed one. The 2 integrated circuits in the middle each provide 2 retriggerable one-shots, and I only needed 3 in total. And way on the right, you'll see that there's a little tiny transistor which actually amplifies the current that gets output by the last one-shot to become 20 milliamperes to flow through the LED. Normally, logic circuits like one-shots can't output 24 milliamperes. If I connected such a load to them, I would burn them out. So there's a transistor that amplifies the current without modifying the voltage much. And then there are the resistors that actually determine the current connected to the LED. Now, below the breadboard, there is a rectifier module, or a bridge rectifier module, which was designed by professionals and which I bought off the shelf. Now, there's a fact that I should point out about this, which is that normally you wouldn't need such a complicated circuit to do what this circuit does. At 120 volts AC house current, a much simpler circuit will do this. You really only need a circuit that's this complex if you really want to regulate, let's say, a 600 volt AC power supply leading to a motor, or some such load, similar conditions. And that pretty much ends my video.